Open up your previous Generating Primes notebook, link below. Go ahead and make sure that you've run all the code. And I want to do something special with this, and that's look at Mersenne primes. So we've done this before. So what's a Mersenne prime? Recall a Mersenne prime is of the form 2 to the n plus 1. And the question we're in is a prime number, say 2 to the p for prime number minus 1. And the question would be, well, how do you know if it is in fact prime? But now, if you're generating primes like this million prime list, we have all the prime numbers that are less than 6 digits, right? So we have our 100 prime list. Now, if you start taking 2 to really big powers, it's going to get, well, let's see what happens, okay? So we've got a list of 100 primes in here, or primes less than 100, right? And we can loop through that to generate a nice list of Mersenne primes. So for prime in 100 prime list, what are we going to do here? Well, we're going to find the Mersenne primes. So we're going to do 2 to the prime minus 1, but we want to add that to a Mersenne list. So Mersenne primes. And this is going to start off empty, and we're going to append this to it. Now, I'm wondering how Python will do with these large numbers. Okay, well, let's find out. And so let's just try them all, and then we'll have a list of potential Mersenne primes here. Okay. I forgot, I got error, which is great. Errors are awesome learning opportunities. It says list object is not callable. It's pointing to the list area. And I can see that I left off dot append. Okay, so we'll run the code again. And you can see it's taking some time, okay, because we're forcing it to sort of, compute like very large numbers, 2 to very large powers. So, and it could be that we've passed the limit, like maybe 2 to the 97th isn't going to work in Python. And if so, we can certainly shorten the list. So once you get into this world of big computations with math, it's not difficult to really slow it down. And what we can do here is we can shorten the list, right? Like if we take the first 20 numbers, recall that we can do that with slicing as such. Okay, that'll be the first 20 numbers in the list only. And I'm going to go ahead and stop it. Feel free to let yours continue to run. And let's try it again. Okay, so now I'm only going to do the first 20 numbers, and hopefully this will work. And you can see there they are, and this is what I mean. Look at how huge they get, right? I mean, it's pretty cool. And so we've got to figure out what's the cutoff point for us to check primes. It looks like it's here, right? Like here's a 6-digit number. The next one is a 7-digit number, which is over 1 million. And so we can check the first 1, 2, 3, 4, 5, 6, 7, 8 elements to see if they're prime. And we basically have the code to do this. Okay, so here's how we would do that. So we've got 4, we'll call Mersenne, in Mersenne primes. And again, we're going to restrict ourselves to the first 8 elements in this list. We want to check, okay, if Mersenne is in, okay, the prime list, I think for us that's called 100 prime list, then we know it's actually prime. And so what we're going to do, we're going to compare them. We're going to make a list of actual Mersenne primes. We'll start it off empty to Mersenne primes. And so what we're going to do then is we're going to append the actual Mersenne primes if they're actually prime, right? So let's just go over this code. So I'm starting with actual Mersenne primes. Hey, we don't know if they're actually prime, but we're going to find out. We're going to check the first 8 ones. And if this is this list above, and basically, hey, if it's in our list of primes, we know it's prime, so we add it to the list. If not, we don't. And what we're going to do then is we're going to compare, we're going to print out the actual Mersenne primes and compare those to the first 8 Mersenne primes. Okay, so hopefully this makes sense. We're actually checking here to see whether they're actually primes. You know, Mersenne postulated that they were, finds out, well, we'll see. And you can see that they are not, right? Like, so 2047 is the only number, isn't that amazing? 2047 is the only number less than 1 million that is not a Mersenne prime, meaning it's not actually prime. All the rest are, in fact, actually prime, as this verifies. So, you know, if we check too large of numbers, our primes only go up to 1 million. Wait a minute. I don't want to check the 100 prime list. I want to check the 1 million prime list. I think the 100 prime list is bigger than anticipated. Let's try that again. Okay, I wasn't checking the largest list. We've got to check the largest list. And when we check it, if it's in the 1 million prime list, we add it, and it looks like we get the same result here. Okay, so 2047 is not prime. According to this code, the rest of them are. I'll double check the code to make sure and let you know if something is off. And I don't know, it's really cool, right? So we can find also the prime factorization of 2047. And how would we do that? Well, we have our list of primes. And so for, let's just say P for prime in, and I've got my 1 million prime list. Okay, so I just start checking them all. I mean, that's more than enough. We want to check if P mod, or sorry, if 2047 mod P was equivalent to 0, then we break out and we share that number. So we break and then we'll print out what's the prime number. Okay? And so let's run that code. It's 23. So we can check now 2047 divided by 23, and we get 89. So the prime factorization of 2047 is 23 times 89. So you really get a lot out of this. You know, you can do a lot with prime numbers. Have fun with it.